Hello everyone, welcome to lesson number 29 for BC Calculus, where we're talking about how to find area underneath a curve. I just want to say that usually when you're doing area between a curve, you are given the functions that you want to find the area between, and you're also given bounds. You're given bounds, and in this particular first example that you guys see right here, we're finding the area of the region bounded by 1/2 x squared minus 2, the x-axis, x equals -1 and 2. So I've already drawn the function that's here in pink, your function 1/2 x squared minus 2, and then I also bound it by -1 and 2, and then again by the x-axis. So one thing that I want to just stress with you guys, and we'll talk about this in the bottom part of this example, is that when we're finding the area of our region, we're going to always use our bounds. We're going to always integrate from -1 to 2. And what we're going to look at here is that there's two functions that have created this yellow region. Our first function is the x-axis. Well, the x-axis is actually the function y equals 0, because y equals 0, the whole thing. So this is going to be the top of our region, the top of our shaded region. Then our bottom is going to be the function 1/2 x squared minus 2. So as I'm going to explain down here in a second, you're going to take your top function, which is y equals 0, and you're going to subtract your bottom function, which you're going to get 1/2 x squared minus 2 dx. So this integral that you see here is what's going to set us up for our actual area of our curve, the area between our two curves. And so I went ahead and just pull the negative out, and so we'd integrate this function from -1 to 2 of this function 1/2 x squared minus 2. And it's going to be the negative of that. And this is going to be negative 4.5. Okay? Now, I just want you guys to know that this video is not going to be about integrating. This video is just about how to set stuff up. So everything that I'm going to be doing in these problems is just to show you how to set up the integral, because my assumption is that once you get to this value right here, you guys can integrate it by the fundamental theorem of calculus. So why does this work? Why does this work? Why is it always going to be the top minus the bottom? And so I have really a nice little picture here, demonstration for you guys. If I'm trying to find the area between these two curves, and I'm bounding it by a and b, so I'm bounded on the interval from a to b. Well, if I look at the top function minus y equals 0, I'm going to get this region right here, right? So this is everything that's in the shaded region. That's this. So this is going to be the region of your area from your top down to y equals 0. Then this region right here is going to be your bottom region. So this is your top function of your, so this will be the top of your region to y equals 0. So if I were to take this region here and subtract this here, I will in fact get this region right here. So that's why when you're integrating from a to b, you're going to take your top function and you're going to subtract your bottom function. And that's exactly what you will do to find the area of any region. It's that straightforward. It's that straightforward. So let's look at example number 2. And the other stuff that's right here is just kind of more the logic behind what's going on with it. But like I said, for this video, I want to keep it simple, make sure you guys are okay with this. So it says find the area of the region bounded by x squared plus 2, the line y equals -x, and then we're bounded at 0 and 1. So if you guys look at this, we've already have the picture. We've already drawn what the two functions look like right here. We have already bounded for you from 0 to 1, and so we want to find the area of the shaded region. Now, again, you guys can use rectangles. That's what they're talking about right there. But all we have to do to solve this problem is to integrate from 0 to 1. We're going to take our top function, which is going to be the top of our region, which is going to be x squared plus 2. So this is going to be the top. So we're going to do x squared plus 2. And we're going to subtract our bottom region, where our bottom region is going to be the line y equals -x dx. So I want you guys to notice that I have y equals here, y equals here. So then we can go ahead and distribute our negative if we want to. And we're going to get x squared plus x plus 2 dx. And we integrate this. And when we integrate it using the fundamental theorem of calculus, we're going to get 17 over 6. So the area of this region is going to be 17 over 6. So again, ladies and gentlemen, and we have it in the notes for you, this is a really small way of seeing it, but this is our area of our region. So I'm going to write it down here a little bit larger for us. So in order to integrate from a to b, we're going to take our top function, which we're going to deem f of x. We're going to subtract our bottom function, which we're going to deem g of x dx. And that's all you have to do to find the area between these two curves. And the beautiful thing about this is that when you do subtraction, you're going to get that this is actually going to be quote unquote a negative area. It's actually going to fix it and make it positive here. So it actually works out beautiful with this. It's all going to work out nicely. So what if we don't give you the actual graph? Now, you guys could use a calculator if you want to, but usually these questions, the setup really involves just you kind of graphing the function. So I look at g of x, and I'm going to go ahead and say, well, this is just going to be 2 minus x squared. So g of x is going to be negative x squared plus 2 is what I'm going to say with this. So we're going to go ahead and we're going to draw ourselves our little, just making sure that 1, 2, 3, 4. So an idea, we don't have to be perfect. Okay, really all we want to do here is we want to just kind of figure out what's the top function, what's the bottom function, and then we'll talk about the integration part. So this is our function. We know it's a negative x squared, so we know we're facing downward, and then our peak here is at 2. So there's our function for g of x. And then let's go ahead and make brown our f of x. So this can be y equals x. So we're going to draw a line like this, and there we go. We should, in theory, then have a region that we want to find. We want to find the area of this region right here. So we're going to do exactly what we've been doing in the previous example. We're going to integrate. We're going to take the top region, the top function. Our top function is going to be 2 minus x squared. We're going to subtract the bottom function. Even though this is just an x, I always encourage you guys to put parentheses around this because this could be x plus 2, and you want to make sure that you do subtract the entire function and not just the first term, and dx. All right, so that's going to be it. Now, clearly we have to find our intersection points, right? Now, we can look at it here and say that, okay, well, at x equals 1, we intersected, and at the line, it looks like at negative 2. So it looks like from negative 2 to 1, we have our intersection points. Well, there's a really easy way of doing this that you guys already know is, well, they intersect where they are equal to each other, where the functions have the same output. So if you set them equal to each other, and I'm going to make x squared positive, so I'm going to move everything to the right. So I'm going to move this over here, and then factor this. So this is a really easy way of getting what our x values are. And so this is going to be plus, this is going to be minus, so we get x equals 1, and we get x equals negative 2. So you probably don't even necessarily need to draw these pictures if you don't want to. But, like I said, it's always nice to just do a little quick sketch so you guys know which one's on the top and which one's on the bottom. So then we're going to integrate this from negative 2 to 1 of negative x squared minus x plus 2 dx. And then we're going to solve this problem, and we're going to get the answer as 4.5. Okay, 4.5. So there you go. General idea for area between two curves. And that's really what the function is. So let's do one more example. As you guys can see in example number 4, is this on the area of the region bounded by this cubic function, and then the x-axis, x equals negative 1 and x equals 2. So the first thing we're going to do is we're going to factor this guy so we can see where our bounds are. So we're going to go ahead and pull out an x squared. We're going to be left with an x minus 3 here. We're going to go ahead and pull out a negative 1. And we're going to have an x minus 3 here. So I'm just factoring by grouping. And so this function is going to be x squared minus 1, and then x minus 3. All right, so now again, why I like this question so much is that we just need a rough sketch of what's going on here. So we know that we have intercepts at x equals 1, x equals negative 1, and x equals positive 3. And because I have an odd function, and it's positive, then I know that it's going to look like this, right? I know it's going to have the behavior of y equals x cubed. And I also know, just because we can see this here, we have a y-intercept at x equals 3, or y equals 3. So I know the graph's going to look something like this. Again, I'm not going to be too I don't really care too much about how low it goes or high it goes. The graph looks something like that. Because again, we just want a rough sketch. And then the next thing we want to do is we want to go ahead and bound it by the x-axis. And then the other thing we want to do really quickly is we want to bound it by x equals -1, which is right here, and x equals +2, so 1, 2. So what I want now is this pink region. I want this, and I want this. So let me go ahead and move this guy over here so we can actually have some room with this. And so when I look at this problem, you can realize that we have the top function from -1 to +1 is actually our curve, our cubic function. But from 1 to 2, our top function is actually the x-axis. So we have to set this area equation up using that knowledge. So from -2 to +1, from -2 to +1, sorry, we're actually integrating from -1, so that's my fault. So from -1 to +1, so -1 to +1, my top function is the x squared, or x cubed, minus 3x squared minus x plus 3 minus 0. So top minus bottom. And then I'm going to add from 1 to 2. So from 1 to 2, it's going to be 0 minus this top function. This is the first example that I'm thinking that I've done where you guys can now truly see why area, quote unquote, below the x-axis is technically a negative value, even though this area is positive. It's because we took the top function, which is 0, minus the bottom function. So I could essentially get rid of the 0 and pull the negative out. And so that's how you get this problem. And then we integrate this, and this is a very long one that we would integrate, but when we integrate, we get 5.75. 5.75 is our area. Okay, so that is when all of our functions are in terms of x. So we're going to now, in the next video, talk about what happens when we change our curve. What if our curve does not look like we cannot find very nicely a top function and a bottom function? What if we have to go right, left? So I'll see you guys in the next video.